guys, welcome to my picoCTF series. Today we're going to be looking at Mind Your P's and Q's. This is a cryptography CTF and I have no idea what to expect, so let's have a look. In RSA, a small e value can be problematic, but what about n? Can you decrypt this? Okay, so we have some values. Right, let's have a look. picoCTF, make the P's and Q's. What do we have? Decrypt my SuperSIC RSA. Okay, so we need to understand what C, N, and E are in RSA. I confess I don't actually know off the top of my head, so I imagine C could be like the ciphertext, but who knows. Let's have a look at good old faithful CyberChef. I'm pretty sure there's an RSA recipe in here. RSA decrypt. Doesn't look great. Let's have a look at this again. In RSA, a small e value can be problematic. What about n? Okay, can you decrypt this? Okay. So I'm wondering, at first I was thinking maybe this is hex, but it's not hex because there's no AF, no A2F in here at all, just numbers. Decrypt my SuperSIC RSA. Okay, so RSA, let's have a look. How do we encrypt stuff in RSA? Let's do that first. ABC. Please enter a public key. Okay. RSA CNE. Oh, that's funny, isn't it? Oh no, it's not. Okay, I was wondering if this guy had pasted the, if this was the same chat, like if this was the challenge that he was asking for. The RSA CTF tool, that looks cool. Let's have a look. Oh, this is a very popular tool. Retrieve private key from weak public key and or unciphered data. Okay, how does this work? RSA multi-attacks tool, unciphered data from weak public key and try to recover private key. Okay, attacks that don't depend on factorization of integers may depend on knowing any ciphertext. Okay. This looks like the thing that we need. Attack RSA, specify public key or N and E. Okay, yeah. Let's try this, shall we? How do we install this on Ubuntu? Okay, let's just log in and install that. You should do so. Copying and pasting. What's going on? RSA. Let's do it one at a time. Ah, that's why that didn't work. So copying and pasting random commands from the internet, you should be wary of this. I would recommend that if you are going to do this, that you do it in a VM. I am now running a VM for my CTFs because I think it's suicidal not to. So let's run this command again. Cloning into RSA craft tool. Let's then run the second command. This is just installing some requirements. cd into RSA craft tool. Install the requirements for Python. Okay, so we don't have Python on the VM. I think these are the nope. Python 3 pip. Okay, so pip is now included as part of the Python 3 package, I guess. Maybe it was always like that, don't know. Pip install requirements, pip3 not found. Maybe it's just pip. Nope. Okay, apps, sudo apt search pip3. Maybe it's that. No. Okay, pip3 Ubuntu. How do we install it? Python 3 pip. That's what I thought it was. That didn't work, though, did it? I wonder if it's because, so this is like a live ISO. I wonder if I need to enable some sources which are not currently enabled. Let's have a look. Yeah, I have a feeling that we're missing some Ubuntu sources. So let's add those sources. So a source in Ubuntu, you have sources. This is where you can download packages. And my suspicion is that we're just missing a couple of sources. I'm not 100% sure yet, though. Let's check. This is not helpful. Yeah, I mean, that should work. It's not available, it's referred by another package. This may mean the package is missing, has been obsoleted, or is only available for another source. Let's just search for that instead. Ah, here we go, yeah, so we are missing a source, I think. Copying more things from the internet. Don't worry about it. It's a VM, it's only a VM. It's not an issue. And this is 22 though. Main universe, main restrict. Oh, okay, so I wonder if we just need to, we may be able to get away with just changing restricted to universe, maybe. We don't want to install. Okay, sudo apt update, try that. This looks more promising. Install Python 3 pip, there we go. Okay, so it's now working. Yeah, and this is quite common when you're doing pen testing. You'll go down these like random rabbit holes, and you have to resolve them before you can like proceed, which is frustrating sometimes, but that's the reality of the job. Okay, so we're installing the requirements now for the RSA CTF tool. Let's see if we can run it. It looks like we can. And it looks like we can just specify, okay, so if we cat the, where's that file gone? Let's download this file again, values, copy. Yeah, we can put it in here, it's no worries. And then let's move it out. Okay, values, okay, cool. Right, now if I, using this tool, can we, it looks like we can specify, if you run help, you can specify some things like n. So n looks like n is modulus. So this is the modulus, okay. Whoa. Hold on. Okay. So that's the modulus. And e is the exponent, okay. And then we need the cipher, I'm assuming that's ciphertext. Uncipher file. Yeah, I might have to put it in file. Well, let's just see. Whoa, why is that happening? Okay. Private argument is not set. The private key will not be displayed even if recovered. Okay, so we want to show the private key. Dump key, yeah. Okay. So is that the private key then? No, it's identical to. Private argument is not set. Okay. Well, I thought dump key would. Oh, it dumps the variables. Okay, now we want to dump extended dump of the RSC private. Yeah, so ext. We want to do ext. That's fine. Why isn't it? It's still not showing it. Display private key if recovered. Okay. Okay, cool. Okay, we have a private key. That's good. So can we take this now and stick it into CyberChef? Let's have a look. Let's say decrypt. Okay. Count the values again. I'm assuming C is the encrypted thing that we want to decrypt. Okay, that looks like it didn't work. Yeah, because I mean these are just numbers. I'm not sure what C is. I'm still not sure what C is. Key password. Yeah, the digest. I don't know. Okay. I wonder if we specify uncipher a file using commas. Okay, so uncipher a cipher. Okay, so we can specify uncipher. Maybe this will work. Okay, yes it did. Here we go. This is the unciphered data, UTF-8. Okay, so there was an exponent and a modulus. So let's have a quick look at what that is. So RSA exponent. What is the... Right, so N and E is the public key, N and D is the secret key, and only the recipient of an encrypted message knows it. So it looks like N is the modulus. So the modulus and the exponent together, they can be used to create the public key. Okay, and then the modulus and the decryption exponent is used for the decryption. Okay. Okay. Cool. I mean, this is a good tool, and it highlights the fact that even with like state-of-the-art encryption, like this is like a standard. Even with standard encryption, even with like a standard encryption process or algorithm, if you don't get the values right, like the keys and the exponents and the modulus, if you don't get it right, if you use weak values, then you can still have problems. And I guess in this case, I actually don't know. I don't really know what is the problem here. So this is the ciphertext, this is the modulus, and this is the exponent. I mean, the exponent value is very small. This is a very small value. Yeah, it's a very small value, so I'm wondering if that's the issue. N and E is, so the modulus. What is the modulus? Yeah, let's just have a look at this. It's a very old 1977. Yeah, very old. Okay. So encryption, let's have a look. After Bob obtains Alice's key, so RSA is an example of asymmetric encryption. With asymmetric encryption, you have a different key for the encryption and decryption, but the encryption and decryption keys are associated in some way. From the public key, you should not be able to derive the private key, but I guess in this case it is possible. So after Bob obtains Alice's public key, he can send a message to Alice. He first turns M into an integer. Oh, okay. So he turns his message into an integer first, which explains why we had C as a really long like integer. Strictly speaking, this is padded plain text, such that 0 is less than or equal to the message, which is less than N. Oh, okay. So, oh, that's interesting. So N is the modulus. He computes the ciphertext C using Alice's public key E corresponding to C equals... Okay, yeah, so basically download... it's something that I think I would need to read up on. Oh, actually, this is interesting. Oh, okay, here we go. Choose two distinct prime numbers, P and Q. Compute N is P times Q, giving 3233. Compute that function. Yeah, see, this is really complicated math, and I'm not a mathematician. I'm just a pen tester. But yeah, this is something which is beyond the scope of this video, but if you want to learn more about RSA, here you go. Yeah, it's good that this is a really cool tool actually. I will incorporate this into my distribution of choice, which is Maxos and Nixos config, and it is popular, lots of people are using it. I'm not signed in on this profile. So yeah, that's all I'm going to talk about today with this. I hope you've enjoyed this video. If you have any questions, let's actually submit the flag before we go. Here it is. Submit this flag. Okay, good. We have solved mind your P's and Q's. Yeah, I hope you've enjoyed this this video. The next one is going to be static ain't always noise. That's going to be interesting, I'm sure. Okay, you guys will see me soon. Have a nice day. Like and subscribe. Goodbye.